Okay, in this video we'll check out how to find complex roots of any given number, but in particular a complex number. And in in a previous video, as a quick reminder, we talked about if you could find one solution, right? We know that all the other solutions are equally spaced apart with the angle between them and the radius same. Example, if instead we were doing this, right, I know that one of the solutions would be 1. So on the complex plane, we have 1. And because I'm doing a fourth root, all the solutions are spaced out, like take that full circle 360 and divide it by 4, right? Then they're each spaced out by a 90, right? They're all equally, the angle between each of the solutions is equal. And because there are 4, I know that that angle would be 90. And because r is the same, right, 1, then I know r is the same for each of those 4. So we'd have another solution of -1, another solution of I, and another solution of -I. Right? That's great. Remember, we are in the complex plane. This is the real, this is the imaginary. So that is great when we can find one solution, because then we could use that solution to find the others. But if we look at this one, right, x to the 4th equals I don't know what that would be. Right? If I tried I to the 4th is 1. That doesn't work. I could try -I, but that would be -I to the 4th is still +1. I don't know how to find my first solution. So therefore, I'm going to have to rely on this formula. Notice the formula, we need theta and r. All I have is I. So in complex form, right, we know that that's equivalent, I is equivalent to just saying like 0 plus I. And we could use formulas for a plus bi to get this number into trig form, or you could look at it on a graph, right? I know that this is here, so therefore the angle should be 90, or pi over 2, depending if you want radians or degrees, really doesn't matter. And the r is 1. But to verify that, we could go ahead and do our formulas, right? R equals square root a squared plus b squared. So b is the value in front of I. Square root of 1 squared, so square root of 1 is 1. And then you could do tan theta equals b over a, 1 over 0. So you have to think, where is it undefined? Where is, remember on the unit circle, y over x undefined, right? Well, that means x is 0, so we would have either 90 degrees or 270 degrees. But because we moved up, right, I know that it's 90. Theta is 90. Okay, so we have what we need to start this. I know theta, and we're doing fourth root, so n equals 4, so we know theta, we know r, we know n is 4 because we're doing the fourth root. So let's do it. The last piece, remember, fourth root means 4 solutions, so you could just think of it like let k equal 0, k equal 1, k equal 2, right? Keep going until you have 4. So there's our 4 equations we'll end up doing. But it does make sense as well because n is 4 and 4 minus 1 is 3. So that tells me k should go 0, 1, 2, all the way up to 3, which we have. Great. So remember r1 over n is equivalent to saying the nth root of r. Well, in this example, we have 1, right? R is 1. So any root, fourth root of 1 is still 1, cube root of 1 is still 1. So I have 1 to the, I'm going to write it for the first one, fourth root, cosine theta over n, 90 over 4, 90 degrees over 4, plus k is 0 in this one, so I really don't need to do anything else, but I'm going to go ahead and write it, 360 over 4. Notice this part of the formula for sine is the same as this part for cosine, so whatever I get here, I could visualize 90 over 4 plus 0 times 360 over 4, right? I would have 90 over 4, that's not a pretty number, 20, what is it, 22.5? Yeah, 22.5 degrees, and then plus 0, right? Okay. Well, if we can evaluate this, right, which again, cosine is also 22.5, so we have 1 cosine 22.5 degrees plus I sine 22.5 degrees. If we could evaluate those angles, you can, right? That way we know exactly what the solution is. But 22.5, no special angle, right? Not on the unit circle. Often we'll just leave our answer like that. You could plug it in a calculator to see exactly where that lies, but picturing it, 22.5 with a radius of 1, we'll just, 22.5 somewhere right there-ish. And then I'll just say R is 1. Okay, kind of over-exaggerated, I guess, but that's okay. So that's the real, that's the imaginary. Well, we could not use the formula to finish this up if you want, right? Because I'm doing fourth roots. So like we talked about here, once you know one solution, you could find the other 4, or the other 3 in this case, however many. I'm doing a fourth root, so I know that the angle between them is all the same. So I need to go 90, which puts me at what, 112.5? So somewhere there. And then make sure R is 1, so somewhere there, right? 112.5 degrees. And then go another 90, or go 180 from the original. So that would be 202.5 degrees total, right? 202.5 degrees. And then go another 90, again with R is 1. I didn't get out a ruler. I could tell it's slightly off, but that's okay. Not to scale, right? So that angle would be 292.5 degrees. And then you could check, right? Add your last 90 would be above 360. It would be 382.5, but that is equivalent to our original 22.5 degrees. Okay. That's one way. Once you know one, you could find the others. So let's go ahead and use the actual formula though. So when k is 1, again, fourth root of 1, we already know is 1. I don't even need that there, but I'm going to leave it to show that we do have r. Okay, cosine 90 over 4 plus k is 1, right? The only thing changing is this. So 1 times 360 over 4 plus I sine whatever we get. Well, notice that was our original 22.5 right here, right? Plus 360 over 4, which is 90. And that's exactly what we did in the drawing over there. So 22.5 plus 90 is 112.5 degrees. So our second solution is cosine 112.5 degrees plus I sine 112.5 degrees. Okay, k is 2, cosine. Okay, we know 90 over 4. I'm just going to write that as well, right? No point of doing 90 over 4 each time when it's the same result. Plus 2 times 360 over 4. Okay, well that's 180, right? 2 over 4 is a half. 360 over 2 is 180. 180 plus 22.5 is 202.5 degrees. Cosine 202.5 degrees plus I sine 202.5 degrees. Last one, we have k is 3, 22.5 plus 3 times 360 over 4. And that gives us 270. Right, 360 over 4 is 90 times 3 is 270. So 270 plus 22.5 is 292.5 degrees. So the fourth solution is cosine 292.5 degrees plus I sine 292.5 degrees.